Does it start recording?
No, yes.
Now, yes, good. All right. What's the change in internal energy in joules of a system that does, or release, or sorry, release. This means it's minus 154. And does, what does it mean? Is it positive or negative? Hello?
Negative.
It must be negative because it does on the system is doing work on surrounding, so it must be negative. So, and the answer is just add these two numbers. Clear? Good. That's number one. Number two, a system contracts from an initial volume of 15.0 liter to final volume of 10 liters under constant external pressure of 0.8 molar atmosphere. What's the word? Yes.
8 minus energy.
What? The work equal to what?
PV.
No, not PV. P
Minus P delta V.
delta V. The work, the change in the work is actually equal to P delta V. So what's the answer? Minus what? 0.80 atmosphere times what?
Minus 15.
What? Times what?
10 minus 15.
10 minus 15, exactly. And the answer is minus 5. What's the final answer?
4.
Plus 4.
That's 4. No, this is, give me answer for the thing that we did here. Multiply 5 times 8.8. Is it 4?
Yes.
Yeah.
4, exactly. Is it positive or negative first?
Positive.
Positive 4. Is this the correct answer?
Yes.
Now we need it in joules.
No. The unit here is atmosphere times liter. And there is nothing here which is atmosphere liter. They're all joule. What should you do to get rid of atmosphere liter?
Or multiply it by 100
You have to change atmosphere liter into joule. And so what will be the final answer?
D.
Exactly. I don't know. Multiply 4 times 101. Yes, it must be D. Is this clear? Good.
Yes.
3. Benzene is starting material in the pieces of nylon. Okay. Fiber. Okay. Its specific heat capacity 1.74 kilojoule. If 16.7 kilojoule of energy is absorbed by 225 degree L gram sample benzene, what's the final temperature? It was originally at 20 degree. What's the T initial is 20 degree, and T final is what's required. What's T final? How can you do it?
We write Q equal to SM delta T.
Q equal to what?
SM delta T.
MS delta T. Okay. What is Q?
It's 16.7 kilojoule. We change it to joule.
Exactly. What's M?
225.
Why? What's S?
1.74.
1.7. 1.74. What's the only thing that we didn't know?
The delta T final.
T. Calculate it quickly.
$42.65.
So what's the T final?
We'll add 20.
Which is which answer?
62.7.
Good. Number 4, a 3.307 gram sample of unknown material was heated to 98.7 and placed in the calorimeter containing 72.4 gram of water at 23.6 degrees C. The heat capacity of the calorimeter is 15.7 joule per degree C. The final temperature in the calorimeter is 32.4 degrees C. What is the specific heat of the mineral? Okay, what do we have here? We have Q of surrounding, which is the calorimeter. Q calorimeter is equal to what now? First, before we even do anything, what's delta T in this question?
Oh,
32.4 minus 23.
7 what? 76.1, right? Am I right?
If we are calculating for the calorimeter, not
I don't know. If you're calculating for calorimeter, what? Yeah, of course.
32 minus
The delta
23.
T will be negative, exactly. The delta T will be negative in this case because it's for calorimeter. But I want at this time just delta T, okay? Because the calorimeter will absorb the heat, so it will be minus, exactly. So from now, I can put it minus and everything will be positive. Or actually, we can say minus times minus here. And then this will give us the amount of heat. Okay, anyway. No, just let me see. Just to see this. So, okay, good. So let's calculate it for very quickly. What is this equal to? Q calorimeter.
C delta T.
C, which is C times minus 76.1. What's C?
Doctor,
Yes.
Doctor, just could you wait a minute? Look at the second line. The water was 23.6 Celsius.
Yes.
And then it turned to 32.4. Isn't that delta T for the calorimeter?
Oh, sorry. Yes. I'm very sorry. Yes, of course. The 98 was the temperature of the unknown. Yes. Sorry, there is a big mistake here. You're not following me. This is wrong. Okay. What's delta T? It's actually 32.4 minus, this is the final temperature, minus 23.6.
8.8.
So it is 8.8. 8.8. And it will be positive. Oh, You make big mistakes. See, I'm not concentrating myself. So this is also wrong. So, yes, it's 8.8. What's C? Let's see.
15.7.
15.7. I'll put it under it. 15.7. Are we finished with the Q calorimeter? No. Why? Because there is also water, and the water is given to you here. 72.4 gram of water. What's the heat of the water then?
To be 72.4 multiplied by 4.18.
MS times 8.8 also. What's the mass? I'll write it under it.
72.4.
4. What's S?
4.18.
From where you got it? From the periodic table. Okay, calculate Q calorimeter.
Two 2801.3.
2801.3.
3.
Very good. If you know this, what's Q of material? Q,
Will be negative.
sample. It will be minus 2801.3. What's delta T for the sample?
I just got it.
Subtract what from what?
32.4 minus 98.7.
Exactly. 32.4 minus 98.7. Give me an answer.
Minus 66.3.
66.3. Exactly. Now calculate S for the sample. What is it equal to?
Which is 0.138.
0.138. 0.138. Anybody got the same answer? Maybe what you should do, divide this number by 66.3, and of course the sign will go away, and then divide by 307, the mass of the sample, and you'll get the answer. Is this clear?
Doctor,
Yes.
do we always add the Q for the calorimeter and the water?
No, if it's given the mass of the water, yes. If the water, the mass is not given, then you do it for just calorimeter. I mean, this means they include it in the calorimeter. Does this answer my question? Any question?
And if there is no mass for water, then we do it for the calorimeter only.
Yeah. This means the water is included in the calculation of the C.
Okay, it is clear.
Good. Okay. 5. A common laboratory reaction is the neutralization of acid with base when 50 milliliter of 0.500 molar HCl at 25 degrees is added to 50 milliliter with 0.500 molar NaOH at 25 in a coffee cup galvanometer. The temperature of the mixture raised from 28.2 degrees C. What's the heat of reaction per mole of acid? Assume the mixture has specific heat of 4.18 and the density of the reactant is 1 gram per milliliter. So first, to solve this problem, you have to make the reaction NaOH plus what?
HCl.
HCl. What are you going to have?
NaCl plus H2O.
we want to have the delta, H, delta H of this reaction. We want to have calculate delta H. Okay, what's the information that we have? How much NaOH we have? By the way,
100 per mole.
First, is the equation balanced?
Yes.
Yes, so we don't have to do anything with balancing. Good. What's the amount of NaOH? How many moles?
$0.25.
0.25? No. No, there's milliliter. You have to change it to liter.
Yes, I have to change it.
So it's 2.5 times what?
10 to the power minus 2.
Yes, 2.5 times 10 to the power minus 2. Exactly. So what's the value for HCl?
The same.
Is there a limiting reactant?
No.
No. What's the value for NaCl if we want to calculate it?
The same.
Everything is the same. Very good. Now, so we know this heat is for 2.5 times 10 to the power minus 2 mole. I want it per mole at the end. Okay. Now, the temperature raised from 28, from 25 degrees C to 28.2 degrees C. What's Q then?
MS delta T.
MS delta T. Good. We know delta T. The only thing that we didn't know at this time is delta T. What's delta T?
At 28.2 minus 25.
Which is what?
7.
Exactly. What's S?
4.18.
Okay. What's the mass?
It will be 50.
What? It will be what?
50.
No. It's 100.
50 plus 50 because both of them.
Why 100? Why 100? You're adding 50 milliliter with 50 milliliter. What's the total?
100.
100. What's the density?
1.
This means how many grams?
100.
Times 4.18 times 3.2. So what's Q?
One 337.6.
1337.6
Yes.
joules. Very good. This comes from this amount. If I want 1 mole, how much heat?
We'll divide it by 2.5. Yeah.
Exactly. Give me an answer.
$53.5 times 10 to the power 3.
53 point what?
5.
Okay. That's enough for me. So you know the answer. No more. Is this clear?
Doctor, all these Q for the reactant, right? For the system, I mean.
Yes. This Q is for the system, and even 53.5 is for the system. But, well, the system is the reaction itself. No, this Q is for, for surrounding. The water is the surrounding. So this Q that we are calculating is for the surrounding. This is Q for H2O. Okay, and that's why if I ask you what's delta H for this reaction, it should be what?
Minus 1337.6.
It should be minus 54 kilojoule, of course. Is it 54 kilojoule?
Yes.
I hope this is clear also. Okay, let's go to 7. When 0.75 to 1 gram of benzoic acid was burned in calorimeter containing 1000 gram of water. Temperature rise 3.6 of 3.6. So what's this 3.6? Already delta T 3.6. Okay, was observed. What's the heat capacity of the pump calorimeter, excluding the water? Okay, so we don't want to calculate the water in it. The heat of combustion of benzoic acid is minus 26 point. So we're burning benzoic acid 20. So Q of benzoic acid is equal to what? Minus 26.42 kilojoule per gram. If I have 0.75 to 1 gram, then what's the Q?
We multiply it, right?
Okay, go ahead, give me answer.
-19.87, minus 19.87.
19.87, very good. It's kilojoule. It's now without per gram, just kilojoule. Okay, and then if I want it in joule, I must multiply it by 1000. Now, this Q of reaction, what's the Q of surrounding, or the water and the calorimeter?
Positive.
Good. Now, this is equal to what? The Q surrounding equal to Q surrounding equal to
C.
what? Yeah, which is equal to 19, I mean, of course, 19.87 equal to what now? C times delta T plus what?
MS delta T.
1000 times what?
4.18.
Times
3.6.
So everything you have here, this also 3.6. 3.6. Everything you have here except C. Calculate C. That's it. Don't forget to change this to joule instead of kilojoule. Is this clear? Again, look at what's the meaning of excluding? Without the water. That's why we want the C without the water. If it's with the water, it will be with this whole thing. is the C without the water. Good. Question 7. Octane, C8H18, undergoes combustion according to the following thermochemical reaction. This is the chemical reaction, and this is the reaction. Now, once you see this reaction, what do you understand? You understand that this heat will come with how many moles of this one?
2.
2 mole. This one with 25 mole to make 16 mole, 18 mole on this heat. What is the standard enthalpy of formation of octane? Very good. That's not related directly to this one. Okay, good. Now, what's the standard enthalpy? So I'll take this away now. Okay. So, how do you solve this problem? Delta H equal to what? Summation of heat formation of what?
We'll bring the H of octane from subtracting
Repeat.
delta H from the others.
No, delta H formation product minus summation of heat of formation of what?
Reaction.
Yeah. Okay, let's apply it. We know that this one is minus 1,000, 1.0940 times 10 to the power 4 kilojoule per mole is equal to what now?
$16 multiplied by
16 multiplied
minus 393.5
minus 393.5. Okay, very good.
plus
Plus
18 multiplied by minus 285.8.
minus 285.8. Very good. Is it plus or minus? Right? And then what?
25 multiplied 0 will be 0.
25 times. So I'm not going to worry about this because this is
Yeah.
equal to 0 already. So what's the only thing I don't know?
2 C6H.
The formation of C8H18. Good. That's it. What's the heat? We have an answer.
500.4.
500.4. No, it should be something.
We will divide by 2 the coefficient of the compound.
I want the heat formation of 1 mole. So after you do the whole calculation, I want you just to calculate. So you divide by 2 maybe.
Minus 25. Minus 250.
Who got the same answer?
Yes, the same.
Let's hope so. Good. Number 8. What's the standard enthalpy of formation of liquid methanol? So we want liquid methanol from this reaction. We want what's the standard enthalpy of formation. How can you do that?
By Hess law. First,
Hess
we'll
law.
put the reaction.
Why? Because what's the reaction that you're looking for?
C plus
C plus
H2
2H2
after dancing.
plus what? Half
O2
2 to make
CH3OH.
H3OH. That's it. Can you make it from these three equations? What are you going to do with the first one? Keep it as it is. C goes to CO2, and this is minus 393.5. Very good. Next, what should I do with the second one?
Multiply by 2.
2H2 plus O2 to give you 2H2O. What will be the heat? Clear? Okay. What can I do with the third equation?
Exchange it.
What?
Exchange it.
Reverse it, yes, reverse it. CO2 plus 2H2O to give you CH3OH. So what's the heat?
Positive.
726.4. Good. Now, anything available in both sides, cancel them.
CO2 with CO2.
What again?
CO2 with CO2.
CO2 will go CO2, very good. What else?
2H2O with CH2O.
H2O will go to H2O. What else? It must be. Let's see. This is something. Oh, I forgot 3 over 2. Yes, but plus 3 over 2 or 2, yes. 3 over 2 or 2. I forgot this. See, I forgot this. Rewrite the equation. Last equation, I forgot to write something, which is what? CO2 plus 2H2O to give you CH3OH plus 3 over 2 O2, and the heat will be plus 726.4. CO2 will be CO2, 2H2O will be 2H2O. What else?
Half O2. When
One of this one, and only 1/2 of this one will go away from this one, and
we remember.
with 1/2 O2, right?
Yes.
And the reaction will be C plus 2H2 plus half O2 to give you CH3OH. And what's the heat?
Minus 238.7.
minus 238 point what?
7.
7. Excellent. Can you see the answer?
B.
Good. Sodium peroxide N2O2 react with liquid water. What's the first thing you're going to do?
Write the equation.
Yielding what? NaOH and oxygen gas. Okay, what's the second thing you'll do? Hello? Balance the equation.
Balance the equation.
How are you going to balance it? 2 and then
Half O2.
no, it is balanced. Yes, I agree. 2, 1, 3, 2, and 1. Yeah, very good. Done. Okay. And oxygen. How much heat is released if 327.2 grams of oxygen of gas is produced? So we have 327.2 gram O2. How much heat? Just a second. We don't know what's the H for this reaction. No? You have to calculate the H. Calculate the H. Can you calculate that H first before we write this?
It will be minus 142.5.
You did it already?
Yeah.
Okay, delta H is heat formation. Okay, what is equal to summation heat formation of what? 2 times heat formation of NaOH. Right? What? And then O2, I don't care about it. And then minus heat formation of Na2O2, which is minus 510.9, and H2O, what's H2O? Also minus, and we don't have to multiply anything but 285.8. So give me a final answer.
Minus 142.5.
142.5
5.
kilojoule. This is per how many moles of this is for how many moles of oxygen?
16.
Half mole of O2.
Yeah, which is 16 grams.
16 gram O2. If I have 320 or 327.2 gram, then what's the heat?
It will be 2,914.
2000?
Minus 2,000, but it will be positive.
Positive, whatever. No. This one. Oh, this one was negative or positive?
Negative.
Then it's negative, the same thing. But yeah, I don't have to put the negative because I already told you what.
Released.
Release. What does that mean? I don't have to put the negative. You don't have to put the negative because you know there is a negative, but I did not put it because it's released. Okay? And that's why, what's the answer? 29.5.
2914.
Good. Okay. Using Hess law, Do the reaction here. Can you do it?
Yeah.
Okay. What are you going to do with first equation? That's the heat. Second equation, what are you going to do with it? Yes? Why? I want to cancel this one with this one. So when I reverse, what will be the heat?
Positive.
Okay. What are they going to do with the third equation? Reverse it and divide by 2. So O goes to half O2. What will be the heat? Now, add them together. The ozone will go with the ozone. The O2 and half O2 will go with 3.5 O2. What will be left? NO plus O to give you O2. What's the heat?
Minus 306.
Minus 300. What?
306.
That's the solution. I solve now all the quiz. All right. With this, I'll stop, and I need a break, so I'm not going to take any more questions. Thank you. Have a nice day.
يعطيك العافية.
مع السلامة جميعا.
الله يعطيك العافية يا دكتور.